This is the first in a series of 4 videos that will highlight the Math 8 curriculum. We will begin with our first 9 weeks. In the first 9 weeks, we will cover Pythagorean Theorem and the number system, transformations, and solving equations conceptually. Let's take a look at the Pythagorean Theorem and the number system. This unit is 20 days, which includes time for assessment. This unit begins with working with perfect squares and perfect cubes. In the 2019 Math 8 course of study, exactly how far students need to know perfect squares and perfect cubes to is defined. So students only need to know their perfect squares up to 225 and their perfect cubes up to 1000. We then move to approximating square roots. This will be done both geometrically as well as on a number line. Students will then discover the Pythagorean theorem, apply the Pythagorean theorem, and find the distance between 2 points on a coordinate plane. We are not teaching the distance formula. Students will apply the Pythagorean theorem to the coordinate plane. The unit ends with a distinction between rational and irrational numbers. So the reason that the real number system and the Pythagorean theorem is linked is when students are solving Pythagorean theorem problems, they encounter these non-perfect squares, and they learn there that it creates a need for identifying what classification this number is. By the end of this unit, students should be able to answer the following questions. Why does the Pythagorean theorem only apply to right triangles? What determines an irrational number, and how do I locate its approximate location on a number line? And how can you use the Pythagorean theorem to solve real-world and mathematical problems? Unit 2 is transformations. This unit is 13 days. We begin with an introduction to transformations. So this is done using activities such as Pac-Man to illustrate the different rotations, reflections, and translations. And we also do this with and without coordinates. We then further investigate translations and reflections on the coordinate plane with a move to dilations, and finally sequencing transformations. So being able to look at an image and then and see what combinations of transformations were taken to the pre-image. By the end of this unit, students should be able to identify what happens to a figure when it is translated, reflected, rotated, or dilated. When using transformations, how are angles, side lengths, or figures changing or staying the same? How can you represent a transformation on a coordinate plane? And how can you recognize congruence and similarity in figures? The last unit of the first 9 weeks is a mini unit, solving equations conceptually. This lesson is five days. In this unit, students will read and interpret algebraic expressions, solve equations, variables only on one side. Students will be introduced to variables on both sides in Unit 6, which is the first unit of third 9 weeks, and match equations to real-world scenarios. How does knowing and understanding the order of operations help when isolating a variable? So this unit will help students to make connections from what they learned in 7th grade when they learned two-step equations in 7th grade, to begin to apply that process to what it's going to look like here in Math 8. And that is an overview of the first 9 weeks of the Math 8 curriculum.